Alrighty, good morning, good afternoon, good evening, depending on where you are in the world. My name is Sue Macaluso, and I'm kicking off the CA Performance Management Tech Series for OpenAPI and JavaScript applications. Today I have with me Jeremy Rosbach and Jason Normandin, and they're going to take you through this tech series. I think it's number 6. So everybody knows if you have any online questions, you can ask them in the Q&A chat window if you look in your WebEx on the upper right side. The guys will also pause to communicate verbally if you'd like to ask a question on the line. You would just have to hit #6 to unmute yourself. By default, all lines have been placed on mute. And with that, I will turn it over to Jeremy, and thank you for joining.
Thank you, Sue. And I'm actually, guys, just putting in a few URLs for you in the chat window that I'm referring to right now. So, again, like Sue said, thank you all for attending. This has been a really fun series. I think we're into number 6, but I may be wrong, but that's great because we've held so many and we have some more coming that we're just losing track of the count. So really, really, really fun stuff. And today we are talking about JavaScript. We may have to move some topics around here and there according to our resources and schedules, but we definitely are juggling a lot of great technical topics with this series, and the audiences always seem to be growing. So just a few points, and again, I put these in the chat window. If you missed some of the technical webcasts in the past, the replays are here. And again, that URL is in the chat window. If you haven't seen it yet, there is a top 5 reasons to upgrade to the latest version of CA Performance Management 3.1 ebook. Again, that URL is in the chat window. That'll take you directly there. Each of the top 5 reasons have an associated YouTube video that dives much deeper into that technical enhancement. And then, of course, the webcast that we gave last week, I believe it was on the 5th, last Wednesday. For those folks who may have missed it, the What's New webcast in the latest versions of PM and VNA, the replay link is there in your chat window as well. So, again, thank you very much for attending. We're really excited to have you on for these technical webcasts. And, Jason, I'm going to turn it over to you. So I'm throwing you the ball now.
Thank you, Jeremy. Appreciate it. And thanks, everybody, for taking some time out of your day once again to join us. Jeremy said this is lots of fun. You know, we put a lot of time and effort into our API and to make it as easy and extensible an API as we could. And what we're finding as we explore through this webcast series and other things that we have a lot of flexibility, and there's really some great opportunities for both ourselves and for you folks as well to just drive more customization, drive more value, and make the tool more and more something that is a perfect fit for your organization. So I'm going to talk a little bit about the API in general, talk a little bit about JavaScript, and then we're going to kind of walk through an example, and we're going to leverage we're going to look at our weather map. And this is a new weather map that is just published to GitHub this morning. And this one leverages Google Maps as far as the Maps integration. And it also comes with a couple of helper apps to help you define your geo-coordinates and your connectivity and just to make things a lot easier for everyone. So I'm going to start with an overview. When we talk about OpenAPI, it's more than just our, the OpenAPI that exists on the data aggregator to pull CAPM. Can anyone, just want to make sure you guys can see my slides. I just got a note that someone couldn't see that.
I can see it, the CAPM OpenAPI, yep.
Okay, yeah, if the question was if we're going to share them out with the physical slides, absolutely, that we certainly can do that, not a problem. So the API is more than just the extraction mechanism on a data aggregator to get configuration and performance information, right? It's across our ecosystem, and it's building as a platform is what our goal is. So we have our OpenAPI, the OData-based API, which is focused on data and configuration extraction, and it's really end-user focused in that it integrates all of the necessary authorization and authentication and single sign-on and everything else that makes working with APIs very difficult. We've removed all of those from what things you have to think about, so you can just focus on doing interesting things with the information that you're able to get. But there's more APIs, right? We have our REST APIs in the data aggregator, and those are primarily to drive administration capabilities, right? So they're more about setting items or defining things rather than retrieving information. So whether that's configuration data, metric families, vendor certification, things like that, things that are focusing on asset information and being able to work dynamically with that asset information. We also have an API in CAPC, and that is, providing automation for provisioning and configuration tasks, whether that be groups or users. It unites our data sources and allows you to gain much simpler access to other data sources that are sharing information with CAPC. It does this through basically lookup ID conversions, which makes calling other APIs very easily because you can drive the context, and I'll share more about that in a moment. Being able to get custom content, context-aware custom content, whether that's through importing and exporting of dashboards, whether that's using our URL system or whether that's using our browser view in our new, introduced in 3.1, our new app view. So it's all focused on the CAPC is all presentation layer, basically, right? So it's all about unifying the data sources, it's about providing context, and it's about providing opportunities to integrate custom visualizations, custom data, anything else that will make your experience or your user's experience better or more tailored to meet your specific needs. UIs are tricky. There's really no UI that's a one-size-fits-all. So what we're trying to do is do the best that we can out of the box, provide a lot of smart defaults and a lot of simple operations, but really allow you to take it to where you need it to be to provide as much value to your organization as possible. We'd like to keep you in the platform while we're doing that. I understand a lot of customers like to get the data out into a data lake or something else, but we feel with the opportunities we've made for contextual aware integrations that bringing that content in can be just as compelling, if not more compelling, in many situations. And then Spectrum. Spectrum is another API that's important. Spectrum provides inventory, alarm, and topology information through its REST API. So you can get model info, model topology information, alarm, event information, lots of stuff. And the nice part about that is Spectrum has very nice APIs as well. Allows you to take information that you can get from the CAPC API or the OData API to make those calls to Spectrum very easily. In a future webcast, we're going to show some of the stuff that we've been able to do just with some JavaScripting and pulling over Spectrum neighbor topology information into device context views. So just a sneak peek there. Keep your eye out for that. We'll be adding another event to the session where we're going to focus on Spectrum integration. Brian Jackson will be joining me for that one. And that one's really exciting because what we're finding is you can do a lot with just a little bit, and that's kind of what I learned from JavaScript in general. You can accomplish a lot with just a little bit of knowledge. You'd be surprised what you can do. So the OpenAPI, the data flow of an app. So we're going to be focusing on that specific focus, right? So we're going to get data out of the system, and we're going to use it to render our custom geomap. So how does that work? What happens? So when the data flow for an OpenAPI app occurs, so the user's going to authenticate. They're going to log in through CAPC, through our SSO mechanism. They're going to then open a dashboard or a context page, and in there's going to be an OpenAPI app, right? So they're going to access that app, which is going to call our OpenAPI. The OpenAPI exists on our data aggregator, right? So we can't just call directly from APC to the data aggregator because that violates a browser security requirement that doesn't allow when you're communicating with one server, it doesn't allow that server to go and get information in the same session to pull back and give that back to you for a lot of obvious reasons, but you can do a lot of spoofing that way, so that's not allowed. So to mitigate that, we added a proxy to CA Performance Center. And in 3.0, that proxy allowed us to go and query the OpenAPI on the data aggregator directly as if it was locally hosted on CA Performance Center. That way we're avoiding firewall restrictions, all those other things that would prohibit users from being able to leverage our OpenAPI apps within CAPC itself. So the CAPC proxy takes care of all the redirection and all the stuff that you never need to worry about. The OpenAPI will then use the context information to validate that user, make sure they have permissions to view what they're trying to view, get that information from our data repository, pass that back up into the CAPC proxy and back to the OpenAPI app. The nice part about this is the only parts that you need to worry about are really the app. Everything else we take care of for you, just to make it that much easier so you don't have to worry about that. And I don't have a slide to update this, but we've also added in 3.1 another proxy. And this proxy allows us to go to the DA REST web services on this slide the same way. So again, if you were to call this into CAPC browser view, and that browser view called an app which made a call to the DA REST web services, that wouldn't be allowed. So what we have to do is we have to proxy that and make it look like it's actually simply a request to CAPC, which then goes to the DA REST web services. Again, nothing you need to worry about at all. The calls are the same, everything is the same. It's just one less thing you need to worry about. CAPC, we don't have that problem. And now we're also looking at adding a Spectrum proxy as well, so that, again, you'll be able to call the Spectrum API from CAPC without worrying about all of the other infrastructure that goes along with that. Again, really wanting to allow you to focus on doing things with the data, not worrying about how to get the data. That's really our goal. Let me skip through this slide again. So an example, so that an app will get context from CAPC browser view window. Let me go back. And I'll show you that in a moment. It gets that context information, and that's everything about what's going on, right? That's the dashboard, the user, the locale, what the time range is set for, the current context, whether it's a group in a dashboard or an item in a context page, all sorts of information. Everything that you would need to tailor the experience to meet that contextual situation the user finds themselves in. And that's really important, right? We stick apps out there that are not driven through the dashboard context. It's very disjointed. You can certainly do that for things that don't change, but if you're pulling data, live data out, that data needs to be, the calls to that data needs to be modified based on what you're trying to get, right? So if I'm looking at a group called routers, my OpenAPI query and the app that's using that query, we don't want that to be hard-coded, right? Because, well, you have to have a different app for every group. That would be ridiculous. So we can just simply pass information from CAPC directly into our OpenAPI queries in our apps to basically call over in context and get the data specific. And I'll show you what that looks like in a minute as well. We can also, then another thing, OData would build the query using those parameters that I mentioned, and then the app can query the DA REST API to set item attribute information as well. So we're gonna look at an app that's gonna exercise multiple aspects of the API with our weather map, both through the DA REST web services and through the OpenAPI REST services, as well as using the CAPC contextual awareness in our browser view or in 3.1 in our app view. So we look at what's available in a browser view or an app view in 3.1. So item information, the item ID, that would be the local CAPC ID, and then for the DA, there would be a subsequent ID for that particular item. That's important because usually when you're doing programmatic development, you're writing calls to APIs against IDs. We make it easy so that you don't have to go find the ID. We just give that to you, which simplifies, your query significantly. Things like the name, the item type name, the username, the role, these are all things that you can incorporate as well into your app to continue to tailor. So you can do certain things based on the role, for example, or you can provide information on, the username, anything like that. And then the time start and the time end, UTC format is easiest because that gives a numeric value in Unix epoch seconds, which is very easy to convert in JavaScript to a real date time object, which can then be translated, transformed, everything that you need, localized, all of that stuff, all very, very simply through the parameters that you can pass down through the browser view. So, for example, we know that I can get the ID, the CAPC ID for the North America group, as well as the DA ID for the OpenAPI query. I can get the type name that it's a site. I can get the item name that it's North America. I know the username is admin. I knew the role name would be passed on as administrator. And then I have my start and end times that I'm getting from the dashboard time picker. So think about this. This removes, if you're going to develop some sort of app to show data, all of the work that you would need to do typically to build a context selector, to pick the thing, to be able to allow the user to choose a time frame, to manage, authentication, authorization. All of this stuff is taken care of for you. So again, you can just focus on getting the data and doing something interesting with that data. And that's where we feel, we start to shine. So when this query gets passed down and when this information gets passed down to the app, the query that's in the app can be written very simply based off of the query builder query that I showed in the very first session to basically substitute things like the group ID and the time range, for example, to be able to leverage the specific attributes that are being passed down to that app from CAPC. So again, taking all of the work out of your hands and letting the system do it. The system knows all of this information. It's easy to pass down. It's easy to digest into the query. And then what you get, very, very simply, is custom data sets based on the specific context of the CAPC UI at the state it was issued. So you can see how a query in Query Builder transforms into leveraging the parameters, item ID, DA, time start, time end. You can see how it's very easy to substitute that information directly in your query and pull down information, again, that's going to be custom tailored to that particular experience at that particular time. So if you look at all of our views in CAPC today, all of them look at the context, all of them look at the time range, all of that stuff. It's the same way with apps. You don't have to do that. We'll do that for you. You just need to understand, where that app lives. Is it a dashboard app? Is it a context page app? And in 3.1, we've actually even made that a lot easier for you to control and make sure it works just as well, and I'll show you that as well in a moment. So app development, we have documentation now to help with this. So in 3.1, we added formalized OpenAPI application publishing, and we've basically promoted the views to be a standard view that you can just drag and drop. What drives this is this app.config.properties file that would be contained within each application, and it's going to provide all the information that our system needs to know what this, how to call this app, where it should be called from, meaning is it a dashboard, is it interface context, is it device context, is it multiple, the URL, which is basically our way of getting that context from PC to the app. Height, so you can, you can define for a particular app how big that view should be. So if you're building a specific experience, you can make sure that when the user selects that app in a dashboard, it's going to look exactly how you plan it to look. Description, name, things like that. And then you can see for our context, you can focus it on device, interface, server, router, group, or you can do none, and it appears in all contexts. So that means that it'll show up everywhere. Otherwise, if you only want it to show up in interface context pages or device context pages, you can easily do that simply by specifying a value for that parameter. And this is just a plain text file. It just has to be called app.config.properties, and it has to exist in the root directory of the app. The apps that we publish on GitHub already have this in. So what you can do is simply, as I'll show you, you can just download the zip file from GitHub, deploy it through the UI in CAPC with a single click, and then add that view to a dashboard as you would any other view. And I'm going to walk you guys through exactly that. So we're going to look at a weather map for a case study. So this is, like I mentioned, a new app that was just published this morning that leverages the Google Maps Map API, as well as the OpenAPI and the DA REST API to allow you to both create and view weather maps. What is a weather map? So it's a geolocation-based view, which is showing device-to-device connectivity, basically. So if you think of it, for example, maybe it's my WAN branches and the connections between those. It could be any other manner of items that you want to show where you're looking at that abstracted relationship. It's not a layer 2 topology, right? So it's not meant to show you every hop along the way. It's meant to show you the general health of things that are connected in a geographic area. And that geographic area can be the world, it can be a more specific area, and basically whatever you want to see. We had an initial geomap published on GitHub that leveraged a D3 visualization. What we found was that in certain circumstances, it became an issue with overlapping information. So if things were very closely tied together, it didn't handle the scaling as well as Google Maps does. It didn't handle the zooming as well as Google Maps does. So we went ahead and we built out a map directly to leverage Google Maps. So what do you need for the weather map? So you need at least CAPM 3.0. 3.1 is preferred for two reasons. One, app publishing in 3.1 is super simple. And two, we don't have the proxy to the DA REST API in 3.0. So the setting of the attributes for the device geolocation and the connectivity, that's something that you would have to do either manually or install those into the data aggregated Tomcat web server, which is actually pretty complicated and prone to problems. One of the reasons why we went ahead in 3.1 and created that proxy. So I would recommend if you want to do this yourself, that get 3.1 up and running in a lab and start there. You're going to have a much easier experience. It's way more drag and drop and way more friendly to be able to implement this. And we'll actually go in and I'll show you some of the aspects of the JavaScript that you might be interested in changing or tweaking. So what do we need to do to make this? Well, the very first thing we need to do is there's a new attribute that we'll need. And this is going to be an attribute called connects to. And that is going to be an attribute on our interfaces. So this is basically going to say, hey, an interface on this device, which other device does it connect to? So it's going to be a string, and that's something that you create through the DA REST services. You only need to do this once, so I didn't build an app or anything here because this isn't something you need to do more than one time. Once you create this, it exists for all interfaces on the system, and all interfaces can be configured, how you want them to appear or not appear in this weather map. Then what you want to do is create a group. You can look at creating groups based off of geographic or based off of functionality. You can look at, for example, I use some rules to look at aliases to understand, automatically create groups based off of those combinations of things. But you can manually create the groups as well by adding the devices that you want to show up on the map, and then the interfaces that are going to connect those devices. So you would add all those things to a group, and then you would use the apps to create the geolocation information for the device. So here's a screenshot. I'll walk us through this again. So basically what you do is you pull up this app on the device context pages, and you can automatically just type in a location. It'll call Google Maps API. It'll bring back the longitude, latitude. It'll create a location description string for you that you can very easily override. It'll show you a little map to make sure you're looking at the right thing. You click a button, it'll go and it'll provision, it'll define that REST endpoint. It'll set those values. And then what you need to do is you need to wait for the CAPC sync or the OpenAPI ETL job for that to run to pick up those newly added attributes. So there's a little bit of a delay here. So you want to kind of plan this out ahead of time. So you can kind of build all, figure out, I want to connect these 5 devices. How do they connect? Get it all down, build that all out. And then by the time you're done, all of these sync processes and updates will happen. I like to set the alias as well. It just makes it a lot easier when you're looking at it in PC to understand what's going on. So, and then for each device that you're going to put on the map, you want to set the connection information, obviously, right? You don't have to. The weather map will work just fine if it's just a bunch of devices on the map. No problem. It'll plot all the devices. Otherwise, you're going to want to have the connectivity. So currently with PM, we're limited to custom attributes on devices and interfaces. So unfortunately, at this point, you couldn't do components. So for example, you couldn't have IPSLA tests as your connection mechanism between sites. And that would be really great. We'd love to do that. We have an item on the backlog to add custom attributes to components. If you are in that situation today, though, and you want that and you need that now, there's definitely things you can do within the script itself if that information can be derived someplace else. There's infinite flexibility with JavaScript. That's the beauty of it. You can get it to work in any situation you want. what I tried to do with this particular example is try to really focus on here's how you do it, here's how it'll work. If you want to go a step further and change how it's working, that's why GitHub is beautiful. You can just fork it, modify it to your heart's content, and you have a fully customized version of whatever you're looking at. So you set what it's connected to. This app uses a device name. It's just a lot easier from a copy and paste perspective, and that way you don't have to look up IDs or anything like that. And then I like to set the alias again for the interface. It just looks nice, and you get to know that it's, hey, this alias is site A to site B, and it just makes the visualizations look a little more obvious, a little more pretty. But again, you don't have to, but that's kind of what the app is expecting. So then you wait for the OpenAPI job to run and the sync to complete, and then what you get is you get a list of devices that have all their geo-coordinates set, location description, longitude, latitude. So you now have a system that's defined based off of geographic locations, and then the interfaces about which device they connect to. We know which device they connect from because they exist with that device. So it's just about where it's going. That's the information that we need to know. So in Query Builder, for example, you can see I have a bunch of devices and interfaces that I'm using for a weather map group. I have longitude, latitude, I have location, and I have the connect to string. And this is an example that's showing like a full mesh deployment. I have a couple of deployments that I'll show you guys as well. Again, it's taking this query expression and bringing that directly into the app. That's really what we're doing. The app is just making this OpenAPI call, pulling in that information, and then the Google Maps API pretty much does the rest. You pass that information in a certain way. Google Maps API reads it and builds out your map, puts all the things on it, connects them, colors them, all those wonderful things that you want from a weather map. So then it's just a matter of within CAPC, you can confirm everything exists as you expect, that your devices are there, that they are connected in the ways in which you expect, so that when you launch your weather map, things are going to look the way you expect them to look. And when you launch your weather map, you're going to see a bunch of connections. This is looking at a rather large topology across the world. Google Maps does this very well. All of the links I'll show you, you can get information. They're all colored and sized based off of the actual interface information. The devices are colored based off of the CPU utilization, and it's all context-driven and context-aware, and I'll show you what that means in a minute. So visit our GitHub repository to both get these apps as well as to see other apps that are out there. It's growing. We continue to get more and more. So, we're just continuing to add value in the OpenAPI app platform, and something that we're definitely going to continue to evolve as releases progress. So let me share out my browser and we can start actually going through the case study. So I mentioned in the PowerPoint slide we have a best practices now in our documentation for OpenAPI apps. So if you go into our OpenAPI section, you'll see one for apps, basically giving you some best practices or some tips of how to begin, what to do, some best practices when you're writing the app, how to get the app config properties file configured correctly so that it's going to show up in the right spot, how to deploy that application, and again, just some best practices about, working successfully and easily and not having to reinvent the wheel. Downloading an app is super easy, deploying is just as easy, and displaying is super easy as well, as I'll show you. So when I go into our GitHub repository, I've pinned the three apps that we're going to be looking at today. We have a Google Weather Map. If I click on this, we see we have our information here, and all I need to do to download that is click download. And that's going to save that locally. If I want to go and download the other two that we're going to need as well, so our device geotagging app, this is the app that lets me set longitude, latitude. I'll just download that as well. And the last one I'll download is the one that lets us set interface connections. Again, this is all assuming 3.1 because they rely on that proxy to handle the communications between CAPC and the DA REST API. Okay, so we now have those three apps downloaded. So what's the next step? How do we deploy those apps? Well, that's That's a really, in 3.1, that becomes very easy. In 3.0, it was a manual file copy across the CAPC, and then when you wanted to add the view, you had to copy a URL. It wasn't a great experience. We wanted to tighten that up a little bit. It's a great first start. We have big plans continued in this area, but what we're seeing in 3.1 is a lot easier. So I would just go as the administrator, and this is kind of locked down from a deployment perspective to the administrator. Any user can use the apps, or anyone that has permissions to edit dashboards can add the apps to dashboards or context pages, but for deployment, we're keeping it at the admin level for now. All you would do then to deploy an app is you would go to your downloaded file. I say I have 3 of them here. Right now, we're just doing one at a time is what we support, so you just click that. I know I'm replacing an existing app, so I want to overwrite it. I'll click Add. That app has been, if it's the first time, it'll say deployed. I already have it, so it'll say replaced. And then I would just do the same thing for the interface connections. Click Add. And then I would do the same thing for the geotag and click Add. Now you have, just through those 10 seconds of steps, you have 3 new custom OpenAPI apps deployed on your CAPC system. So how do you go ahead and use those? Well, we know that we're going to be using a device context page to set device information, an interface context page to set interface information, and we know we have a map that goes on a dashboard. So let's just look at a device. So I'll just pick this device here. It doesn't have any connection information currently. Longitude, there's no longitude, latitude information defined. And what I want to do is I want to deploy that app that lets me go ahead and define exactly where something exists. So to do that on a context page, it's real easy. You just click Add Tab. So I'll just put geotag as my title. It doesn't matter, you can put anything you want. And in 3.1, we have this new app view. In 3.0, you could use the browser view, but there's a lot of manual steps you need to configure as far as URL goes. But I'm just going to drag my app view over. Well, which app is it that I'm dragging over? Well, it's all of them, but only the ones that are set for device context will show up. So on my app view, I'll select my app dropdown, and we see I have this device geotag app that we deployed. I'll click that. It fills in the description. It automatically configures the URL, the height, all the information that the app expects to be there to function properly. Click Save. And now what we have is a custom OpenAPI app that whenever I click on a router context page, a new tab will be available that lets me define my longitude, latitude for a particular device. So let's just say this particular is in Istanbul. I'll search Google for Istanbul. Okay, that looks right. So Istanbul in Turkey, very good. Automatically tells me the longitude, latitude information, parses out a location description for me. I can change that. So I want to do Turkey, I can do Turkey. And then I can click Save Device Location. And if it's successful, you're going to see that a message that it's been set and to wait for the sync process to view in CAPC and the ETL OpenAPI job. For the sake of the demo, I'm not going to do that. We're going to just keep on going, and we'll use items that I've pre-configured. So there's our devices. So that's a real easy way to get all the geo information for the devices. That's part 1 of the weather map. Well, we also want to show connectivity. So for that, we're going to look at interfaces. Again, we don't currently support components. In the future, you'd be able to use something like IPSLA or anything else like that to be able to do that. But for now, we're going to look at interfaces. So I click on interface. I already have the app deployed, so I'm going to pretend I don't, and I'm going to add a new tab. And I'm going to call this Set Connection. Again, very, very simple. I'm going to go and go to External Links, drop in an app view. I know that it's an interface context because I'm doing an interface, so it should show up in my list. Oh, wrong one. Interface Connections. App which allows users to connect to device using the device name for use in the OpenAPI weather map. So you can see, again, automatically the URL is built out, the size, all that information is there. So what I do is I save that, click that there, and now what I'll have is this particular app will now bring up information that tells me, okay, which device does this connect to? So I can add a device here that I want. There's an autocomplete that is not currently working for some reason, so that's something I'll update and push to GitHub. So let's just say this is going to 10.8. So basically what this is saying is this particular interface on this particular device is going to connect to this device. Now you might say, well, it actually connects to an interface. That's true, and we can certainly, or you can certainly update the weather map to do it that way as well. But for now, from a simplicity perspective, the goal is to show the connectivity, not necessarily to show how each interface connects to each other. But it just so happens the way we built the weather map, that information is inherently available, and I'll show you what that means. So I click that, and I say my connect to is successful. Wonderful. So now, after I've gone through and figured out everything that's connected, I want to look at that. And in 3.1 as well, we added an inventory hierarchy screen, right? So in one screen, I can look at my group hierarchy. I've created a couple of groups ahead of time. I have a full mesh group with 3 sites that are all interconnected. We have one in Seattle, New York City, and San Diego. And then we can see the interfaces associated with those. Again, I set the alias just so it's really easy to see. So this is Seattle to New York to Seattle, Seattle, San Diego, et cetera, et cetera. And I also have a GeoMap hub and spoke example focusing on 5 sites in the U.S. With a hub and spoke connectivity. And then I have a much bigger GeoWorld view that has a multiple number of sites across the U.S., across Europe, across Asia Pacific, be adding Latin America as well soon. It's really up to you how many things you want to add. And then I see my interfaces that I've configured here, the connectivity, again, the device they're connecting to, the device they're connecting from, where they're going to, the connects to string, and then this is basically everything you need for the app. So then how do you go ahead and build the OpenAPI app? Well, that's really easy as well. So I'm going to change this for now to a group that I know does not have any geo coordinates, because I want to show you, what things look like in general. So I can add a new dashboard. So I'll add it in the My Dashboard screen. So I'll just put the Add Dashboard view, or you could add a view to existing dashboard, but for demo's sake, it's pretty easy this way. So I'll add a geomap. I'll call it geomap. Again, we're looking at external links, and I'm just going to drag the app view over. I know that my geomap is supposed to go on a dashboard because the app config properties file tells me that. So I bring that app over. I can change the name. Let's call it geomap. I'll select that geomap. Oh, where is it? Is it not published? Did I goose something up? Where is it? Why was that deployed? Okay. I must have goofed something in my properties file. Okay, not a problem. I already have one deployed. I'll take a look at that properties file as soon as this is over, make sure I might have had a typo, why it's not showing up in the dashboard view. So not a problem. Piece of cake, because I actually already have it deployed as well using the up. See, now I broke it. All right, let me fix it real quick. I'm going to share out my desktop so you guys can see the magic, so you're not sitting there wondering what the heck I'm doing. So I'm going to go into my GitHub repository here, open up my Google weather map, open up my app config properties file in a text editor, take a look. I'm going to change this to no context. I'll save that out. And I open up my GitHub desktop app, and I'll re-push those connections. We see that this changed. So that we're going to do update context, click sync, and then I'll download another version of that. Refresh. Whoops. And this was updated, we see 14 seconds ago. We know that's the right one. Download zip. Save that. So again, we're going to go to my dashboard. If I hit refresh, it should not work. No, okay. Google, did I change the name? I might change the name. Google Dash Weather Map, that's why. All right, so I'll update this information so you guys don't have to worry about it. Google Dash Weather Map. It's still not showing up as published either. Okay. So plan B. I'm going to copy the zip file. Sorry about that. Like I said, I just pushed it this morning. So must have had a tweak in that. So again, history, and then we're going to go zip-r. We'll do it Google Weather Map.zip. Actually,
guys, I know we have questions in Q&A, and we'll hit those when Jason wraps up here.
Yeah, let me just get this copied over. So I'm going to do a manual copy over to CAPC rather than fool around with. Why that didn't work? It's very strange. So Google-weathermap-master. I think that's where I'm going wrong. All right. So Google, yeah. So it's the app deployment didn't function properly. But that's okay. So let me deploy the app from this local folder, and that should work for me. Documents, Google Weather Map, deploy that, replace existing, add, app replaced. Now we should be able to go to the dashboard, refresh. All right, okay. Now it's working. So if I open up again the view settings for this app, you can see the network weather map is now published. So something with the way that it was pushed to GitHub, again, I'll take care of that. So I'm pointing at a group that doesn't have anything in it as far as devices, so I just get a blank map. And this has all the standard Google Maps controls, zooming in, zooming out, change it to satellite view, whatever you want to do, it's all there. And if you notice, it's also themed, and I'll show you what that is in a minute as well. So, this isn't the default Google Maps color, but it matches CAPC a lot better. So we noticed I had my groups deployed, right? So I have my full mesh, I have my hub and spoke. So now it's as simple as selecting that group within the context. So if I click GeoMap full mesh, boom. So now we get a connectivity that shows me my New York, my Seattle, and my San Diego, as well as the connections. And when I mentioned don't worry about connecting interfaces, here's why. Because from the visualization layer, we're going to do that for you. So the way we show these connections is we draw the line halfway between each, and they meet in the middle. And so this is the interface that's going from San Diego to New York, and this is the interface that's going from New York to San Diego. We show availability, we show utilization, errors, discards. We color the line based off of thresholds for utilization. These are defined in the app, and I'll show you that. We have a goal to eventually expose all these settings in standard browser view settings, but for now, this is still something that has to be done manually. What you'll also notice is that we list the interface, the source, and the destination device, and that these are all hyperlinks. They're hyperlinks because if I click on them, we're going to bring you to the CAPC context page for those items. This is another new feature that we added into 3.1 as well, to automatically handle redirecting from an ID to CAPC. So to be able to get to the context page, it's super, super easy now within the apps, and it really brings these things to life. So if I look at what I got from my hub and spoke group that I created before, you can see it simply renders the different view. All of the data being put on the map is all driven through my group and my time range. If I were to change to last 8 hours, it's going to re-render. Some of the lines may be different. You select a device, you get the device information with CPU, IP address, location. Again, you can click on the context to go to that device page. And then I have a large group that shows me my geo world, which has multiple countries and allows me to look at more complex topology information. So we have, for example, Helsinki, and if we look at the connections, Helsinki looks like it connects to London, Helsinki to London, and again, all the information that we need. So you're looking at the true definition of a weather map. This certainly meets that. You'll notice issues with Google Maps. When you zoom out too far, it tends to duplicate areas of the world. I'm working on an update to the app that, depending on which things you're looking at, it'll automatically zoom and center the map accordingly. But for now, you can just, again, use the standard map controls to see. We can see I have a link that's going from Sydney to San Diego, but I haven't yet built the link that goes from San Diego to Sydney. So that's something I'll do. And then what will happen is that line will just magically appear after those synchronization jobs occur. So if you follow the paradigm of devices, geotag them, interfaces to connect them, you can basically build any maps you want. You can also have multiple maps on the same dashboard. So if I wanted to edit this dashboard, I could change my layout to a 2-wide layout. I can go and I can do an external link and deploy another app view. This time I can select the app for the geo world. The ID is going to be the item ID of the group. So one way, if you wanted to pin this context, for example, you could put the ID of one specific group. So if I wanted one map for Asia Pacific, one map for North America, you can do that. I'll just do a duplicate copy for this example. But you'll see now we have 2 maps. They look identical, but if you wanted to do something clever like this, you can start to kind of build out a display however you need it. And again, once the custom zooming is there, and driving these through the groups becomes very, very simple. Google does a nice job with automatically scaling and resizing, so zooming in, out will work. Browser size, you can, there's no requirement as far as a 1, 2, or 3 layout, and you can change things like the satellite view, terrain, etc. What I want to do now is, before I dig into the JavaScript a little bit, I'd like to take some questions because I know that's probably something that we want to talk about first. Let me find out where my questions are.
Do you want me to start reading them out to you, or you just want to go to the top?
No, I got it. No problem. Okay. Thank you, though. From Marco, different level of authentication to use the REST OpenAPI for different levels, meaning I have another tenant who wants some data out of the DA, but I want to give them full open access. So that's a really good question, and I'm glad you brought that up. So the way that we've configured this in 3.1 for the proxy is we are giving users access to the data aggregator REST API based off of the username in CAPC. So out of the box, it'll just be admin, but you can configure that and you can add other users. We do not yet have basically the means to filter operations based off of the user in those DA REST APIs. So if you give someone access, they're going to have access to, at least through CAPC proxy, they'll have access to the DA REST API, and then whatever is being called, they'll be able to do. You can, if you build it properly and look at the context of the role of the username, within your app, you can just add a quick check. If you take that parameter in and say, if admin, then let them do an update. If not, then don't. So you can control that pretty simply in the JavaScript with just one if conditional. Can I set the geolocation coordinates from the device alias since I already have them in there? You could definitely automate that and write this app. The apps that I have published basically are relying on going in and just clicking the locations. And for scale purposes, yeah, driving that through automation, driving that through some sort of script can definitely be done. We have really good APIs around that, so it's certainly doable. And I know there's lots of people doing lots of interesting things with sites, and I see you have thousands of sites. Yeah, so you're going to want to look at some sort of automation there as well, and that should be something that's not too hard. If you look at my app as an example, you'll at least have the REST calls that you'll need to understand, et cetera. But yeah, you can do that. And the nice part about having thousands of sites is Google Maps will do a good job of showing those and handling the zooming. If you're looking at building out, for example, a tiered hierarchy like I have here with GeoWorld, so I have my GeoWorld, but then I have underneath it Europe, North America, APJ. So if I just click North America, the map's going to be redrawn just focusing on those items in that group. So you could break them out because showing 2,000 sites on one map might be a bit overwhelming for the users. So you can kind of tier them, and then the map will just automatically work there that way. I see there's questions coming on chat as well. I'll get to those as soon as I get through these here. From Bali, what's the suggested approach with apps and tenants? Where should install admin be done? The tenant, default? This should be done by the super admin, the true admin. Multi-tenancy isn't something that I've monkeyed around with too much on these apps. It should work because it's using the exact same systems as everything else, so I wouldn't think there's any concerns. But a deployed app will be available on all tenants, so there's no tenancy yet from an app deployment perspective. Certainly, you don't have to use those apps and dashboards to certain tenants and things like that, but everything else in the product and the OpenAPI is all tenant aware, so this will all work based off of your different tenants, but you would only deploy it one time as the primary admin. Can you show how to delete a connection between two devices in a weather map? Yeah, I definitely could. You would basically just zero out that string and remove the item from the group. That's all you would need to do. So I'm not sure if the app allows you to do that yet. I can put that on the list of things to look at to do. Removing that connection would be interesting as well. And I'm also looking at other ways of creating these connections and relationships, so it's not as manual a step-by-step process. But at least the app removes all of the rest overhead and having to do it all through API. Great for automation when you're doing 20 or 30 things. It's probably a lot easier to do it this way, but as you mentioned, if you have thousands of sites, you're probably going to want to do it a different way. So you would just remove the device from the group, zero out the connection string, or you don't even need to do that. If you just remove the interface from the group, it's no longer going to be part of the map. It's pretty simplistic how this works. There's not a heck of a lot of logic other than, hey, what's in this group? What has longitude, latitude, and what has connections? And it's going to show those things, and it's not going to show anything else. If there are multiple interfaces, connections between two sites, will they all show up? Not yet. So we can definitely look at aggregation. In 3.1 for our Viptela SD-WAN solution, we have a map that leverages multi-link aggregation. This app here does not yet do that. It's certainly something we can look to add. But we can, again, the OpenAPI can handle that very easily, that link aggregation, and provide you with an aggregate view. And then it's just a matter of making sure the tooltip has the information that you understand. So if you have a active and a passive, or two active, three active, that's something that we can put on the list for things to look at in the future, as well as leveraging the maps that we're going to be making available as GA software this year. So we wanted to provide an app for flexibility, open source, make it really easy to do what you need to do. We'll have a productized out-of-the-box version. Focus is initially going to be on SD-WAN or on Viptela, but we're going to relax those restrictions as well to make it something more consumable and be able to handle those aggregate interface use cases, et cetera. Will this work with IPSLA components? Sorry, not yet. Since this requires a custom attribute, or at least this app function is looking for that connects to custom attributes, we don't yet support custom attributes on components. And IPSLA test is a component. So unfortunately, the way this is built, no. Could it be easily adopted to do that without custom attributes? Yes, absolutely. It's just a change in the logic of the app and the OpenAPI call that's being made. But you could look at something like the alias or even the name of the IPSLA path and pull out the part that shows how things connect. And then most of the logic as far as building the connections, building the map will all be the same. It's just that starting data set. I'm going to go up to the chat. Yep, we're going to share the slides. The hierarchical view, so that's a new view we added in 3.1. So we have a new view type called a inventory hierarchy view. And that view basically, as I showed, was just going to let you view inventory information based off of a hierarchy. More details on our sprint demos. I went into a lot of demo here, so I have an example here where I'm showing devices, interfaces, and IPSLA components. You can show up to 3 sections here, and you can control which ones you want to see. Selecting device in the devices sections will filter the views below. I don't have any IPsec tunnels for that device, but here are my interfaces. I can go ahead and I can change whatever group, and it's going to, once again, control what's there and then filtering down correspondingly. So it's a nice way to provide a lot simpler view of the inventory rather than relying on a single inventory item at a time and then changing the dashboard scope. This is just a more interactive way to do this. Do we need a license to use the Google Maps? Okay, yeah, so technically yes. So the app that I posted on GitHub is using my Google Maps API key, which is free up to 50,000 views per month. If I have to worry about that, I'll be pretty happy with the success of this particular app, and then we'll work to get a more a Google Maps license not tied to me. You can get your own free one, and then you'll specifically have 50,000 for your call, and you can just update the Google Maps call with your API key. Really easy to do, documented pretty well on the Google API site. But this one, you can just use mine. It's free. I don't think you're going to have anything. I'm not expecting to hit 50,000 views in the short term. If I do, I'll be super stoked. And I'll make sure, you know, either teach everybody how to get their own or update with a CA Enterprise. We're looking into that now, as a matter of fact, because we want to build a Google Maps version of the maps we've developed for 3.1. So we're looking at that now as well. So you don't see that option in 3.1 version for the hierarchy. So let me show you exactly where that is. Make sure there's not a disconnect here. So if I edit the dashboard, there'd be a section called Navigation and Lists. If you expand that section, that's where you're going to see all of our inventory lists, and right in the middle, that inventory hierarchy view is there. Opening up that section, you can see I can control, do I want to look at devices and components, just devices, just components. I can pick what type of components do I want to look at. Okay, interface on one, maybe I want to look at firewall statistics, whatever it may be. So you can really drive that experience to be custom for what you're looking for. You can pin the context like you can in all our other views. If you always wanted to show it as one specific part of the group tree, you can certainly do that as well. But that should be there for you in 3.1. If it's not showing up there, then there's a problem, and we'll probably want to get technical support engineering to take a look at why that's not occurring. All right, I think that's it I have for questions. There is a poll. I'd love to get some feedback about how likely are you guys to actually go and either use or I think more importantly, start building or customizing your own OpenAPI apps. And the reason I ask is I don't expect everyone to be JavaScript and web developers. What we're hoping is that we're able to make this easy enough where either folks on your team that have this experience can assist, or we'll have enough examples and enough types on GitHub that you'll be able to take something we already have and tailor it to meet your needs. So I'm really interested to understand where we are today. Do we feel that this is now in a better position to let you take more advantage of this, or how much more work do we still need to do? Because it's all about removing the barrier to entry. I don't expect everyone to become a JavaScript expert. You don't need to know very much HTML or JavaScript to use this, and especially if you're going to just take advantage of what we have. But I'd like to understand if those expectations are realistic, reasonable, or if it's a pipe dream and we need to look at an approach to make it even much more simple. So feedback would be greatly appreciated. If we want to, I think all the Q&A has been answered. If we want to open up the line to any live questions, that's fine as well. Otherwise, that's all I have to show today.
If anybody would like to ask a question on the phone, just hit #6. It'll unmute your line. All right. Doesn't sound like there's any questions.
Okay. And then if anybody has anything that come up after, reach out to me. I'll figure out what the heck's going on with the GitHub push that it was like an hour before this, so I didn't have a chance to verify it, but I'll figure out what it is. It's probably just something really tiny. I'll fix that, make sure that all works. And again, those 3 apps you need, I'll share this presentation as well. I'll post it on GitHub with the weather map too, so you'll have all that information in one place. Download it, go to town. If you want to open up the zip file, take a look at the files. I can give you just a brief overview. So we look at Google Weather Map. You're going to see the app config properties file. We have the CSS that we're using, any images we're using, and then everything's basically here. We have the lib where we're using D3, jQuery, and a couple other JavaScript libraries. These are all MIT freely available. And the license that we publish with this also is an MIT-based license, meaning you can do whatever you want with this code. You can make money with it. You can use it in production. You can use it at home. It doesn't matter. And then when we look at the index HTML file, this is the whole kit and caboodle. So this is the entirety of that app. Here's where you can define your colors that you want for red, orange, green. Here are, I talked about themes, so you can change different themes. There's a great website out there, and I'll share that on the GitHub site as well, that has all these pre-configured Google Map themes, so you can get it to look exactly the way you want. I added a few that I really like to the script. Here's your scales for your color range, so it's just saying that, you know, green, yellow, orange, and red. So you can set those values accordingly. This is where it determines how thick the line should be based off of the speed. So saying the speed between this and this, a range of 1.5 to 3.5 in thickness. Again, you can customize that as much as you want. All the apps typically ship with a demo switch, so if you add a demo equals 1 parameter to the URL in the app view, it'll load the demo data set, and that's a good way to check if it's working. There are 2 OpenAPI queries called to draw all of this information. Here they are. Pretty straightforward calls. And it looks bigger because I broke it all out to make it obvious, but here's we can see where I'm getting the context from CAPC. There's a lot of logging that I do in the console log. Depending on what browser it is, there's different ways to open that up, but if there's a problem, you should see why, as well as a lot of information about what it's built, what it's trying to build, et cetera. And then it's just a matter of parsing the data, building out the data sets. This is logic to determine where the lines should meet. Again, things you should never have to change. Here's all the text that controls the hover over. So if you want to change what you see here or add a different metric, you can do that there. Here's the hover over for the interfaces. You can see how this PC redirector source type equals local ID equals blah. That's a little magic redirector we have in CAPC where you pass the local ID, which is the data aggregator ID of something, and it'll automatically redirect to the PC context page for that thing. So you don't need to know anything about it other than the ID, which is really handy. So we can see we have interfaces and devices using the exact same URL, just a different ID. It's really nice how it works. And then that's about it. This is where if you wanted to use your own Google API key, you would replace this section right here, the key, and that's it. So there's really, you know, not a heck of a lot to this, and that's the nice part about these apps. So, you know, digging in and making them our own, even if it's just starting with something simple like I want to show different information in the tooltip or I want to use different colors, that should be something that just about anybody can do. You open it up, make the changes, zip it back up again, load it into CAPC, and then you'll have it customized and tailored for your own experience. All right, so unless we have any other questions, again, I just want to thank everybody for taking some time to join. Any direct questions you have, reach out to me directly. If there's other things that you want to see, the best way to do that is to post that on GitHub in the repository. There's definitely places for all that stuff on GitHub so we keep track of it. Otherwise, you know, during the course of getting all sorts of emails, I can't guarantee I'm going to remember where everything goes. So if there's a request for a change or something like that, put it up on GitHub, because if I can't do it, somebody else can get to it as well. That's the beauty of open source, right? We get a lot of people contributing. A lot of people can drive to make this better relatively quickly. But really, that's all there is to it. And thank you for your time, everybody.
Thank you, everyone, for joining. Thank you, guys. Have a great day.